factoring ax squared plus bx plus c. So far we've factored binomials, we've factored trinomials, and we've factored polynomials with 4 terms in them by looking for common factors. So we've looked for common factors first. We should always do that first. And then if we couldn't do anything more than that, we've looked for, if I have 4 terms, can I break it up and pair them up and look for binomial times a binomial. So now we're going to look at trinomials in this form, ax squared plus bx plus c. It's called quadratic. And we've got a pattern for what we can try to look for in that particular form of a polynomial. So first what we're going to do is we're basically going to take this polynomial here and try to make it 4 terms. So we're going to make it into 4 terms and see if we can pair them off is what we're going to do. So to factor this, we're going to make a list of factors ax squared times c. So we're going to take our first term and multiply it by our last term. We're going to find the pair that has a sum of bx. So do we have a pair of factors that equal ax squared times c that also have a sum that when I add them together equals bx? I'm going to split bx into some of the 2 terms. So I'm going to split this middle term, break it up into those 2 terms I just found, and then factor by grouping, so pair them off, which will probably make 0 sense to you right now. Let's put it into play and see how it works. So we've got 2a squared plus 5a plus 3. So first thing I was going to do is look for a common factor, and I don't see one. So then we're kind of stuck. So at this point we say, well, wouldn't it be nice if there were 4 terms? Because if there were 4 terms, I could see if I have 2 pairs, and I could see a binomial times a binomial. A lot of times when we multiplied a binomial times a binomial, we had 2 like terms, we could combine them and end up with a trinomial. So let's see if we can back that up. So what we're going to look for is we're going to say, what's the product of 2a squared times 3? And then 2a squared times 3 is 6a squared. And so I want to have 2 numbers that have that product that also have the sum of this middle term, which is 5a. So to do this, I'm going to list out all the factors of 6a squared. So I have 1a times 6a, and I have 2a times 3a. That's pretty much it. There's really not a whole lot of factors for 6. So now I'm going to see what is their sum. Well, 1a times 6a is 7a, and 2a times 3a is 5a. So I'm going to take these 2 terms, and I'm going to break up the 5a into 2a plus 3a. So now I've rewritten this 3 term, this trinomial, I've written it as 4 terms, 2a squared plus 2a plus 3a plus 3. So notice if I was going backwards, again, all I'm doing here is taking my multiplication and working backwards. If I took the 2a plus 3a, I would get that 5a, that's that middle term. But now since I have 4 terms, I can pair them off and see if I have common factors. 2a squared plus 2a, I can take a 2a out of there with 2a plus 1. Now remember the magic here. This is what I want to have happen. I want to have, that's what in these parentheses, be exactly the same as each other. So I'm hoping since I have a plus 1 in this first set here, I can get a plus 1 in the second set. And look, that works. I take out a 3 and I get a plus 1 as the second set. So that means one of my binomials was a plus 1, and the other binomials is these 2 leftovers here, the 2a plus 3. So these 2 binomials multiplied together give me this product here. So these are the factors of this product. Pretty tricky, huh? All right, so let's see what we can do with another quadratic that's in that same form. Again, ax squared, there's a 1 in front there, ax squared minus 8x plus 12. So I'm going to look for common factors first, and I don't see anything that I can take out of all of those, each of those 3 terms. All right, so let's see if I can break this middle term up into 2 factors, into 2 different terms that have a product of ax squared times c. So x squared times 12 is 12x squared. So I'm going to go through the factors of 12x squared. Now, since I want a positive product and a negative sum, I want to have a sum of negative x, it must be 2 negative factors. Because a negative times a negative will give me a positive product, but a negative plus a negative will give me a negative sum. So I'm going to make that list of factors be all negatives. So negative x, negative 1x times negative 12x, negative 2x times negative 6x, negative 3x times negative 4x. And then I go through the sums and I realize that this combination here has a sum of negative 8x. So these are the 2 that I'm going to use. I'm going to use negative 2x and negative 6x. Remember when I have to split them into the 2 pairs, I want to make sure I have plus in the middle here. So I'm going to scooch that negative over so it's inside the parentheses. Break those down, take out a common factor of x. Hopefully I can get x minus 2 here in the next one. In order to do that, I have to take out a negative 6, not a positive 6. And then I break it down. I have x minus 6 here, and x minus 2 is my second. So I've got this binomial times binomial to end up with this trinomial, because I end up with negative 2x plus negative 6x, which gives me a negative 8x. All right, let's look at a couple more. I have x squared plus 2x minus 15. So again, I want to look for a product. Actually, first I want to look for a common factor. So is there a common factor in all of them? Nope. So next I'm going to break this up into product of x squared times negative 15, which is negative 15x. So I need a negative product, which means one negative and one positive. However, I want a sum of positive 2x. So that means the positive factor needs to be the larger of the two. So I'm going to do negative 1x times 15x and negative 3x times 5x. And the second combination gives me a sum of 2x. So I'm going to split these up. I put the negative 3x in this first set, so I didn't have to worry about the negative hanging around in this parentheses here. Break those up, take out some common factors. Oh, look, things are working out well here because I have x minus 3 in both of these. So we end up with x plus 5 times x minus 3. And you should be able to work backwards, and if you multiply these together, which we were doing the first half of the chapter, if I multiply these together, I should come up with that product. Easy to check. Easy, easy to check. All right, one more. 8x squared minus 4x minus 24. So again, I want to look for a common factor, and I do have a common factor here. I can take out a 4 here. So this starts to look kind of like a factor tree. That 4 should be in your list when you're done, because if I don't put the 4 in as one of my factors, I won't get this product when I'm done. So it kind of looks like that factor tree where you're like, all right, it's a 4, it's kind of prime, I can't break it down anymore, but it needs to be in your final list of factors when you're done. So the 4 just kind of comes along for the ride here. So I've got 2x squared minus x minus 6. So I need 2x squared times negative 6. I have a negative product again, so one positive and one negative factor. But I want a negative sum, which means the negative factor has to be larger of the two. So I'm going to list my negative factors, the larger. So 1x times negative 12x, 2x times negative 6x, 3x times negative 4x. This is the magic pair that gives me a sum of negative 1x. So again, I'm going to split these two up. I listed my negative first here, so it didn't get chopped off with the parentheses. Break them up into two pairs. I'm going to factor them out. In this case, I get a binomial of x minus 2 when I pull out my factors. These two ones that are hanging around here are the other binomial. So I actually have 3 factors here when I'm done with this one. 4 times 2x plus 3 times x minus 2. So I've got 3 factors there. So again, what we're doing here is we're starting by looking for a common factor, see if we can find one. If there's not, our next method is to say, well, can we pair them? But if there's 3, we can't pair them. You'll have one extra kind of hanging out. That's not going to work. But we can take a trinomial and break it up into 2 pairs if it has this pattern to it. And it's got to have the ax squared plus bx plus c. If it doesn't look like that, this won't work so well. So pay attention to that particular pattern. So this is how we factor ax squared plus bx plus c.